Hi guys, welcome back to another movie. This time, because I've received some questions about the nuclear atom and some of the problem solving, I thought I would create a quick film on conversion factors using the nuclear atom as a guide. And so the questions that I'm really going to try to address are these questions that come from the nuclear atom exercise. And they're really all about mass and conversions. And this is something that we'll be using a lot, and so I thought this might be a good archive video. So I have up here, and I've highlighted the one of the boxes from the model that we received for the nuclear atom. That's the one that tells me what electrons, protons, and neutrons look like in these models. And also, very importantly, it has a conversion factor here. It tells me what an atomic mass unit is in a more familiar unit, in grams. And so it allows me to take something that's listed here, like this number in AMU, and convert it to an actual number of grams. So that's what I hope to do in this video. So let's get started. I'm going to come down here, and I'm going to try to address this question. It says, what is the mass in grams of one H1 atom? So I'm going to come back up here, and this is it. That's the one we're looking at. And the only information I have is its AMU count. So I'm going to write that down, 1.0078 AMU. So let's see. Let's put that right in here. I have 1.0078 AMU. Okay. And what is that? Well, that really is the same thing as 1 H atom. So we're just going to put down some information that we know. I also know from this guide up here what an AMU is. It's equal to a very small amount of mass in grams. So maybe I can write this one down, that 1 AMU equals, let's call it 1.66 times 10 to the 24th. So let's see, 1 AMU is equal to 1.66 times 10. Oops. I have to remember how to do that. There we go. 24. And that was in the unit grams, right? Okay, terrific. So at least I have that information down here. So what do I want to do? I want to turn this value into that unit. So how would I do that? Let's see. Okay. Well, I know that whenever I have an equivalent statement like this, I can turn it into a ratio. I could say 1.0078 AMU over 1 hydrogen atom. Or I could say 1 hydrogen atom is 1.0078 AMU and place the hydrogen atom on top. So I know that I need to find grams in my problem. That's what my problem asks me for. So I'm going to use this ratio, and I'm going to write 1.66 times 10 to the, and I made a mistake earlier, it's minus 24. Let's fix that up there. Minus 24. And I'm going to come back and do this. Place this underneath. Is equal to 1 AMU. And then I'm going to say, okay, but you know what? That's what I'm looking for, and I need to put my unit there. Sorry, grams. How can I get grams but get rid of 1 AMU? Oh, I have this conversion factor, which says that if I have 1 AMU, that's the same thing as 1 hydrogen atom. Let's see if Mathematica likes me. So what it did is it took this number, and I'm sorry, it wasn't 1 AMU. Let's go back and fix that up. 0.0078 AMU is 1 hydrogen atom. So let's see if I can get this to recalibrate for me. There it is. And there's our final answer. It says that a hydrogen atom has this mass, not in AMU, but in grams. So I'm going to try the same thing, and hopefully in a little bit more streamlined way. I'm going to cheat a little bit, and I'm going to take this argument here. I'm going to come down here, and we're going to plug this in down here. But this time I need to get a different value because it says a carbon-12 atom. It says the carbon-12 mass in atomic mass units is exactly 12 AMU. So I'm going to come down here, and I'm just going to remind myself, okay, so 12 AMU equals 1 carbon-12 atom. Let's do it like that. Okay. So let's plug this in. it looks like I would change this to say 12, and I would say 1 carbon 12 atom. Let's see what happens. And there's my mass of a single carbon 12 atom. This time the unit is in grams. What happens though if I have a larger sample, more than one atom? Well, I have all the building blocks here, so I'm going to take this again. This conversion is going to be really useful for me because it's what's allowing me to go turn something into grams. And you'll notice what answer we had up here. It said per carbon 12 atom. But in this problem it now says, but I want a whole bunch of carbon 12 atoms. So let's just add one more piece to our problem solving. How many carbon atoms am I dealing with? Well, it says right there 4.35 times 10 to the 6th atoms, right? So let's just write, and I need to make sure that my statement says the same thing. So I will say right there, whoops, and I will say C12 atom, and that would be, maybe we would say sample, how big the sample is. So how heavy is that sample in grams? Oh, that sample, because it's containing a whole bunch of atoms, is considerably heavier than the sample that we had earlier when it was only one atom. Okay, and if I wanted to, and I could say sample of carbon 12, if I want a little bit better label, and there you go. There's our answer. I would do the same problem here exactly the same way. I would plug in the number of atoms of carbon 12 right into this statement, and I would use this conversion factor between grams and AMU, and I would use the understanding that every carbon 12 atom has exactly a 12 AMU mass, and I would get my answer. So I hope that tutorial resolves a little bit of problems. I encourage you to practice and play with Mathematica and see if you can solve the problems. So that's it for now.